Hi guys. In this video we will learn about analog programming in PLC. What is an analog signal? How we read signal. How sensor sense the physical quantity and its transmitter send it to PLC. How PLC card convert 0 to 20 mA signal into readable form. And also we will try to make examples. Stay on channel. Keep watching our videos. In our previous video, we learned about digital programming in PLC and made some examples. We know that when we make program in digital logic, we deal with only 2 bits 0 or 1, on or off. These bits came from different switches, sensors, and etc. In this video we will learn about analog programming and try to make programs via using analog blocks. We know that in industry we deal with many quantities like temperature, pressure, flow, level, distance and etc. These values are continuous values. Means they varies with time, and when we need accurate process, then we use analog values. These values came from different sensors, and sensors send the signals to transmitters. These transmitters are temperature transmitter, pressure transmitter, flow transmitter, level transmitter, and etc. Similarly we use analog outputs values to control valves, motor drives, actuators, and etc. Let's see how sensor sense the quantity and send the final signal to controller or PLC. Sensor sense the physical quantity and transducer or transmitter convert them into electrical signal, which is readable to PLC and sends the values to our controller or PLC. These values are in 0 to 5 volt, plus minus 5 volt, 0 to 10 volt, plus minus 10 volt, 4 to 20 milliamp, 0 to 20 milliamp and etc. Analog module converts 0 to 20 milliamp signal into 0 to 27,648 counts. Different analog modules have different resolution. 8-bit, 12-bit, 13-bit, 14-bit, 15-bit, 16-bit or etc. resolution. It depends on the resolution of the PLC card. Here 0 means 0 value. And 20 milliamp means 27,648 value. But PLC has defined standard limits in terms of under range, rated range, over range. So, values less than 4 milliamp are considered as under range values. Values between 4 to 20 milliamp are considered as a standard range. And values beyond 20 milliamp are considered as over range values. Consider the standard table in which analog value is represented in current measuring range 0 to 20 milliamp and 4 to 20 milliamp. And it also showing that, whether value is in range or not. In industry, normally we use 4 to 20 milliamp signal instead of 0 to 20 milliamp signal. Why? The main reason of using this current range is to check the health of signal. 4 to 20 milliamp signal tells us that instrument is healthy, and sending signals to controller. Now we make an example. We have a tank, and its water is using in a process. A level sensor sense the level of tank and its transmitter send the signal to PLC input card. When tank level is low, PLC gives command to valve 01 to open. Valve 01 start filling the tank. When level reach the high limit, it closes the valve 01. When tank level is low it gives command again to valve 01 to open. A level transmitter with a range of 0 to 1000 liter has been installed in the tank with a 0 to 20 milliamp current output. The current signal was connected to the analog input of the PLC. 1. The sensor measures the level in the range of 0 to 1000 liter and its transmitter converts it into the 0, 20 milliamp current signal. 2 PLC controller on the analog input receives the signal in the range of 0, 20 mA and converts it into the digital value, e.g. 0 to 27,648, it depends on the type and configuration of the PLC controller. To further use this measurement, the PLC programmer must scale it according to the measuring range of the level sensor. The scaled value is saved in the controller's memory for further use. Let's make a program in PLC. First of all, we will give name and address to each used input and output. We can check the address in hardware configuration. Input and output start address in separate columns. System start. System stop for emergency purpose. A coil for tell us that system started. You can use this output to tell in field that system is started. First of all, we will make a seal circuit. Attach define tags with system start, system stop with inputs, and system sacred with coil. Add another network for making a logic for level reading. Add another network to make a logic for level reading, which will read and calculate the analog value of water in tank, and also gave scaled value according to set limits, high limit and low limit. We will set these limits according to our requirement. Here we take a look on scaling block. The scaling block take the analog value at in pin and converts it to a real value in engineering units scaled between a low and a high limit. The result is written in out. In our example, level sensor will convert 0 to 1000 liter into 0 to 20 milliamp signal. An analog card will convert this milliamp into 27,648 counts. PLC also have over control range, 27,649 to 32,511, and overflow, 32,767. At 0 liter it gives 0 value, and at 20 milliamp it gives 27,648. Go back on programming page. Attach high limit and low limit tags. Give a tag to bipolar pin. Attach a memory tag of real value to out pin for further use. Now we add a comparator which will compare the level with its set limits and operate the valve. If level is less than 5 liter, it will open the valve 01. Copy the out value tag and paste in comparator first pin. Define low limit 5.0 liter on second pin of comparator. Attach output of valve 01 which we defined in symbol table. Use another comparator which will tell us that tank is full and also close the valve 01. Copy the out value tag and paste in comparator first pin. Define high limit 990.0 liter on second pin of comparator. Attach output of valve 01. This output will close the valve 01 at value 990.0 liter. Now we will make logic for valve 02. Add a comparator which we'll use for comparing the value of level and will not give the open command to valve 02 if level is less than 50.0 liters. Copy the out value tag and paste in comparator first pin. Define limit 990.0 liter on second pin of comparator. Attach output of valve 02. This output will close the valve 02 if value is less than 50.0 liter. Save and download the program. Let's check the program via simulator. Simulator is our dummy PLC. Check on Run P box. Now our PLC is on. Check all our outputs are off, level is low. When we press the start button, our system started. PLC gives command to valve 01 to open. Valve 01 start filling the tank. In this condition valve 02 is close. Because level I less than 50.0 liter. Now we increase analog value of level to check the program. When level reaches 990.0 liter. PLC close the valve 01. Now we check the logic of valve 02. We need some modification in our program. We add another comparator, which will compare the value and open the valve 02. Attach the scaled value tag on in 01 pin. And define 50.0 liter on pin 02. Save and download the program. Now we test the program again. Check when we switch on the system. Level is low, valve 01 command is on. But valve 02 is close, because level is under 50.0 liter. Now we increase level. You see the command for valve 02 is off. Start increasing the analog value. When level reaches the value of 990.0 liter, PLC close the valve 01. But valve 02 is open because level is more than 50.0 liter. Now we decrease the analog value step by step. You see at level less than 50.0 liters valve 02 close. And at level less than 5.0 liter. Valve 01 open to start filling the tank again. So, guys, in this video you have learned about simple analog programming. In next video we will make more analog examples. For further programming stay on channel, keep watching our videos. Thanks for watching.